So most jumpers have landed at their DZ many times before they ever realize that there are numbers painted on runways. Newer jumpers typically are surprised to find out that both wind speed as well as wind direction can change as the altitude changes. And let's face it, a lot of us are using technology to help us plan our landing patterns. And then we're shocked or maybe confused when our app gave us the perfect landing pattern on one day, but then the next day we are landing so far away from our target. This video is going to be all about headings and how that wind data is collected and then used to generate the winds aloft forecasts. So these topics are covered in the sim. However, with their recent rewrite, actually the runway headings section got completely cut. I still think that these are important topics for skydivers to know because it helps out with your situational awareness. So you're going to be more likely to know where to look for aircraft as you're flying your parachute. And also, if you're headed off to a newer DZ, many of these things are items that you can look up ahead of time and get yourself a leg up in getting oriented there. So we're going to start off with the basics. We're going to talk about how compass headings relate to cardinal directions. Then we're going to get into the runway headings, those numbers at the end that I alluded to. And finally, we're going to talk about the weather. So how that wind data is generated and how it's then used in models to give us the winds aloft forecast. So if you don't need the basics, check the timestamps below and skip on to the topics that you are interested in. And with that, let's get started.
So when we're talking about the cardinal directions, this is north, south, east, and west. So north has been designated as 0 degrees or 360 degrees because we're looking at a circle. So if I am standing facing north or 0 degrees, if I turn 90 degrees to my right, that is going to be east. If I rotate again another 90 degrees, I will be facing south. So that will be, I will have then rotated 180 degrees from north. And then if I go another 90 degrees, I will be facing west. So that's why north is 0 or 360, east is 90 degrees, south is 180, and west is 270. And from there, we can also add in the northeast, the southeast, the southwest, and the northwest. And you can just do the math in between if you actually want to know the numbers for those. So how does this relate to runway headings? We're going to be looking at data from two different websites. So one is airnav.com, and this is not the only place that you can get this data from, but this one I feel like is pretty simple to use. And then of course, Google Maps as well, using their satellite view. So why should we even care about runway headings? Well, if you're going to a new airport, it's a way to quickly orient yourself. You're going to be able to understand air traffic better. You're going to know which one is going to be the active runway or what should be the active runway and where you might be anticipating to find air traffic, especially when you're flying your parachute. So let's get into what runway headings are. They are actually these large numbers that are going to be found at the end of any paved runway. They're super easy to see from the air because they're mainly used by pilots, and they're also rounded off to the nearest 10. So when we're looking at this here, we see a 32 that is on the ground. But let's back up and talk about if we were to see a runway 9, because they're rounded off to the nearest 10, that last 0 has been dropped. So we would add a 0. So runway 9 is actually 90 degrees. So that means, if you remember, our 90 means that we are headed east. So that runway 9 is going to be pointing towards the east. If you were to use the runway in the other direction, exactly opposite, what is exactly opposite from east? It's going to be west. You would find that there would be a 27 painted at the end of that runway because at a 0, 270, pointing towards the west. So let's go back to this 32 that we see here. What direction is this facing? So if we add a 0 to it, it means that this runway is pointing towards the heading of 320. Where we're going to find 320, it's going to be somewhere in here, and it's headed off to the northwest. So let's do a few more examples with these. Here, I decided to pick Skydive Sebastian, and if you go to airnav.com, actually, let me pull that up for you really fast so you can see how this works out. So airnav.com. And this gives you airports all over the US. So I'm going to go airports. Let's say that I want to browse by state. I know Sebastian is in Florida, and I'm going to go and I'm going to find that airport is right here. Click on that data, and this brings up all of this stuff. So we're going to talk a little bit more about what we can see here. But one of the things that we get is a very simplified airport diagram. And that's what I've got going on here. So this simplified airport diagram is showing us that Skydive Sebastian actually has two runways at their airport. One is here, runway 10 and 28. And the second runway is runway 5, 23. So what you also may have noticed is, as I kind of alluded to in the previous slide, is that whatever direction is going one way, you just add or subtract whatever it may be, 18 or 180 degrees, and that's the number that you're going to find at the other. So we know that runway 10, add that 0 on, it's actually pointing towards 100 degrees. And this is where people get their runway headings confused. They try to think that, okay, 100 degrees is roughly to the east, roughly 90 degrees, and so east must be over here. But you got to remember that it is pointing to the east. So east is actually over here. And runway 28 or 280 degrees means that west is on this side. Runway 5, which is actually pointing towards 50 degrees, which is to the northeast. So that means that if it's used to the other direction, you are headed southwest. And then we can go and pull up Google Maps to see on the satellite view how this looks. And we can also, if we were to zoom in maybe a little bit more, we can see here is the 10 painted on this end of the runway, the 28 on the other side, 23 here. Ooh, and it looks like I got the 5 not quite in frame there, but there would be a 5 at that on this end of the runway. Let's say that we are going to go to Mile High Skydiving, which is actually in Colorado. And I looked it up on Google Maps first, and I found out that it is at the Longmont Airport. And then I went to AirNav and I pulled this information. So again, we've got the diagram. They only have one runway here, and it's this one, runway 1129. The other information that we can get from AirNav that might be interesting for us is that we can see how long it is. So under dimensions, this is telling me that it is 4,000, almost 800 feet long. So right around a mile in length. So if I'm thinking about my cloud clearance requirements and I know that I should, above 10,000 feet, have a mile in between myself and a cloud, then I can use this runway as roughly my measuring stick. But it just gives me a way to mark off distance by using this runway essentially as a ruler if I know the length of the runway. So that's something that we can get from there. It also tells us our elevation. So at Mile High, they are roughly a mile high. As we can see, their elevation is 5,055 feet. If we go to Google Maps, again, we can see what the airport looks like and that they do only have this one runway. So not going to have to worry about which one is the active runway here, but at Skydive Sebastian, depending on where the wind is coming from, planes are going to choose to take off facing mostly into the wind. That way that the ground speed is slower as well as generating more lift. So if I know where the wind is coming from on the ground, then I have a pretty good idea of which direction planes will be taking off. And I can just watch a few planes that are flying around to confirm what I'm thinking. Another thing that we might also be interested in, just to, again, to be more aware, is that the planes here are going to be doing a left-hand traffic pattern when they're using runway 11. So all of this is information that we can get off of AirNav. And I don't want to go too much further into that because we're getting beyond the basics now. Like I said, once we bring up the Google Maps satellite view, we can again confirm that this airport only has that one runway. So let's switch over to the winds aloft forecast. We're going to be looking at information from the Aviation Weather Center, which is from NOAA. Also, a lot of people talk about using Windy or Spot Assist. And if you have another favorite, let me know in the comments what you like to use. But we're really going to go into how do we get these forecasts to begin with. So there is a variety of data sources that NOAA uses in the United States to collect their data. It comes from radar, it can come from weather buoys, aircraft and pilots actually send reports. Satellite data, as well as weather balloons, are launched. And all of that data is taken into account and fed into these supercomputers. And these supercomputers are able to take and crunch that data and come up with a variety of different weather models. So just a little bit, because I think this part is cool. Weather balloons are launched twice a day all around the world. You can actually go and see the map for the US, all of the different weather balloon locations. And I found an awesome YouTube video from, I believe it was up in South Dakota or somewhere up in the upper Midwest. If you really want to look at how do they attach their data collection to this balloon and what does that look like, it was a pretty fascinating 6-minute video. So I'm going to link that in the description below. And then also at each individual airport, we have these AWOS or the newer ASOS systems. So AWOS stands for the Automated Weather Observing System. ASOS is Automated Surface Observing System. And you can actually call the phone number at your local airport to get the numbers to hear the data that is being collected there about wind speed, wind direction, is it gusting or not? What are the cloud layers at? What is visibility? And so back from AirNav at Mile High Skydiving, when you look under the airport communications, it is going to give you the phone number that you can call to hear this automated weather report. These other numbers down here are actually from airports that are close by, and in parentheses, it tells you how far away and what direction they are from this particular airport. But if I wanted to call this airport's AWOS, this is the number that I would use. So I talked about the weather forecast. So we have all of this data, right? And this data is here from the Aviation Weather Center, and it is using the rapid refresh model. Again, there's many different models that are out there, and the refresh rates can differ across different models. So some are refreshed every hour, some are refreshed hours. So depending on the model that you're looking at, the refresh rates are going to be different. And then you can get this string of numbers here, and I'm going to talk about what this means. So at the top here, this is giving you your altitude. So this is 3,000 feet, 6,000 feet, 9,000 feet, and it goes up to altitudes that we don't really care about as skydivers. So really it's this data from this point here that we care about. This is the airport code that this is coming from. So the EYW is, I believe, Key West. And the way that you read this is the first two numbers are going to be the wind direction. So again, you got to add a 0 because they dropped off a 0 from it. It's rounded to the nearest 10. And then the second two numbers are going to be the wind speed. And then once we get up to 6,000 in this case, we can see that these last numbers are actually giving us temperature. So I put this in table form so it's a little bit easier to see. So from 3,000 to 12,000 feet, that's typically the altitudes that we care about as skydivers. And I have essentially translated this into what these are here. And this was data that was pulled from, yesterday was July 15th. So that's where this data is coming from for Key West. Apps such as Spot Assist, they have said that they use the data from NOAA, of course, but they don't specify which model. And Windy, if you go and look at their website, I don't actually have their app, but I think maybe in there you can also say which weather model you want it to use and where to pull the data from, because otherwise they're taking that same data and they're interpolating. So they're just trying to figure out what the numbers would be at 1,000 feet, 2,000 feet, that kind of thing. So that's why you can have weather apps that give you slightly different weather forecasts, and why we have apps that when it looks at the wind, why those numbers can be different too from one app or another, because it really just depends which weather model they're using, and then how they're interpolating the numbers as well. So this winds forecast, as we can see, direction and speed can change with altitude. Not always. Sometimes it's roughly the same wind direction and wind speed at all the different altitudes, but sometimes it can be incredibly different. Jump run can also be different than the surface winds, because if the winds at altitude are 180 degrees or however far off they are from what the surface winds are doing, your jump run direction can be different as well. So if you've ever wondered why the surface winds were from the east, but my jump run was headed west, because typically we like to jump we like to run, jump, run into the wind. Well, that's why, because maybe the winds aloft are doing something incredibly different than winds on the ground we're doing. And the way this also impacts us is because depending on how strong the winds are in our landing pattern and on the surface, that is going to change what our landing pattern looks like. And then, of course, also the exit spot where we want to be getting out of the plane, that can change. And it's going to change usually from day to day, but it also can change throughout the day, especially if the winds are changing. So these are all reasons that we need to know what the winds forecast is. But because this is a forecast, it is not the actual numbers that we might be experiencing. Sometimes they are perfectly aligned and we can go based off those numbers. And other times when we go up and we jump, we find out that what the wind was forecasting is not actually what we're experiencing. So we have to be careful that we don't get married to the forecast numbers. They're more of a suggestion. And then when we go up on that first load of the day, usually can be a little bit spicy. We figure out what are the winds actually doing? Do we need to change the exit spot? Do we need to change where our holding area for our landing patterns are going to be? That kind of thing. So keep in mind, number one thing to remember, these numbers that we all pull up on our phones, they are forecasted numbers. They are not true numbers. So in summary, what have we covered? We talked about how compass headings relates to the cardinal directions. We then went into runway headings. Remember that they are rounded off to the nearest 10 and they point to that heading. So if I'm reading that number, that runway is pointing me in that direction. And finally, the winds aloft forecast may or may not reflect the actual conditions that we will experience at the drop zone that day. And again, why should we even care about any of this? By knowing this information, we can be more aware of what the jump plane will be doing. For example, on jump run, we can also be more aware of where we might find other aircraft in relation to the airport. And as skydivers, we have to be thinking about what our landing patterns are going to be and how those landing patterns are going to change based on wind direction and wind speed. So if you don't know how to go ahead and make your landing pattern already, we have a really basic video from First Jump Course material on what is the landing pattern and how do I draw one, or how, I'm going to link that in our description below, and a few other videos that you might be interested about as well.
So that was the basics of headings, compass headings, how they relate to runway headings, as well as where does our weather forecast, where do they even come from, and why is it that some apps are showing me slightly different numbers than other apps. If you'd like us to go into a little bit more detail, then leave us a comment down below, or if you have any questions, we'd love to hear those as well. And I will be sure to put in the description box all the different resources that I talked about.
And as always, if you have received any value from this video, we hope that you like it and subscribe to our channel and maybe share it with others.